Assalamu alaikum, Samaira. How are you? Got disconnected. Good evening, Samaira. Assalamu alaikum. How are you? Good evening, Aisha. Hello, Aisha. Am I audible?
Yes, sir.
Yeah, okay. So, did you guys try this question from yesterday?
No, sir.
No, acha, okay, fine. So, I think we can try it now, है ना? So, in the A structure, you can see that all of these atoms are what? Planar, right? All of these carbon atoms are planar. It is cyclic. So, it is cyclic, planar, right? Cyclic planar. And now we have to look at the number of pi electrons. So, we have how many pi electrons? Can you tell me? How many pi electrons are there? Did you guys write the notes? Did you guys complete the notes?
Yes, sir.
Acha, then tell me now, how many pi electrons are there? How many pi electrons? Electrons.
Four.
Okay, so you are just seeing the pi bonds, right? You are just seeing the pi bonds. But if you make the structure like this now, see. Can you write the resonating structure? Tell me now, can you write the resonating structure for this? Yes or no? No. Can you write the resonating structure for this?
Yes, sir.
Okay, so what will happen? This negative charge will move to the next bond. This pi bond will move to the next carbon atom, right? So you'll
Yes.
get a pi bond here and you will get a negative charge here. So can you see this negative charge is nothing but a pi electron only? Yes or no?
Yes, sir.
Anna, so we have how many pi electrons? 6 pi electrons, right?
Yes, sir.
Got it. Okay, so whenever you have the negative charge, that should be included in the pi bond. Sorry, as it should be counted as a pi electron because it is also acting as a pi bond. Right? Because when it moves, it is acting like a pi electron. So we have 4n plus 2, that is equal to 6. What will be the value of n here? What will be the value of n?
One.
1. So tell me, is it aromatic or not aromatic? Is it
Aromatic.
It is aromatic. Very good. Huh? This will be aromatic. Now, in this, tell me, is it cyclic? Yeah, it is cyclic. Now tell me, is it planar? Is there any carbon which is having sp3 hybridized carbon atom? You have to check that. You have 1, 2, 3, 4, 5, 6, and 7 carbon atoms. So you have to check whether all of the carbon atoms are planar or not. They should have only 3 bonds. No one should know of, none of the carbon atoms should have 4 bonds. That is the only thing that you have to look. So is there any carbon atom here which is having 4 bonds, including the hydrogens? Okay, including the hydrogens. You have to look and tell how many 4 bonds in the sense that 4 sigma bonds should not be there. Okay, so planar means all the carbon atoms should have less than 4 sigma bonds. Because if they will have 4 sigma bonds, then the steric number will be 4, and you will have tetrahedral structure, which is a 3D structure. Planar means 2D only. Tell me, is there any carbon atom which is having 4 sigma bond, or all the carbon atoms are less than 4 sigma bonds?
One has 4 sigma bonds.
Yeah. Samaira, kya hua? Why you are not answering? These things are very simple. You have to just look at the carbon atoms, hydrogen atoms. Agar yahan pe problem ho rahi hai, then please tell me. We will do some questions on that now. Samaira, you have a problem, I think. Okay, so I'm going to give you guys questions. And Samaira, specifically you and Aisha, you were not answering. Okay, so, okay, Aisha is not here. Sarah is now here. Aisha got disconnected. So Samaira and Sarah, I will give you some questions on the number of sigma and pi bonds. Okay, you have to count that, and also the hybridization. So it is plain. It is not a planar structure. That is why it will be not aromatic. Not aromatic. Now, whenever you get a ring, and whenever you get a ring, so this is not a fused ring. These are 2 separate rings. So you'll have to look at these separate rings. So we know that this is benzene. This is also a benzene. So both of these rings are what? Aromatic. There is no question about that. Both of these rings are aromatic. If both of these rings are aromatic, the compound is also aromatic. The compound is also aromatic. Okay. When you have 2 separate rings, this is a fused ring. Okay. This is a fused ring. So in this case, you have to look at this ring here, which is the outer ring, because we have only, you have to look at the ring like this. Now, when you look at this ring, then obviously you can see all the carbon atoms, all of them are planar. All of them are connected with the pi bond, or this carbon, or 1, 2, 3, 4, 5, 6, 7, 8, and 9 carbon atoms are there, and all of them have one, or they all have one one pi bond. That means they have less than 4 sigma bond. That is for sure. So it is cyclic. That is true. It is also planar. Now we have to look at the number of pi electrons. So the number of pi electrons is equal to 1, 2, 3, 4, 5 bonds, which will be equal to 10 electrons. Now, if I put in the formula of Huckel rule, 4n plus 2, that is equal to 10, then I will be getting n is equal to 8 by 4. Yes or no? 8 by 4, right?
Yes, sir.
Which will be equal to how much? 2. Correct? Correct, guys? Yes or no?
Yeah, yes.
Yes.
So it is aromatic or not aromatic? Tell me.
It's
It will be aromatic. It is aromatic, है ना? So you have to look at the outer ring. Outer ring means the ring. When you don't have fused. Now this is fused ring. That means you have to look at the outer ring here and check the aromaticity. When you have 2 different separate rings which do not share a bond. So here you can see this bond is shared by these 2 rings, but here there is no sharing of bonds. Okay, so all the bonds of this ring are only for this ring, and all the bonds of this ring are for this ring. These are connected by a sigma bond. These are connected and these are shared. Here the bond is shared. Here there is a connection. Okay, so I think this is clear for you guys. So in last class we started the electrophilic aromatic substitution, and we did for nitration, right? We did it for nitration. We have 4 more. We will do those 4, and then we will look at the effect of group also. Effect of group. Okay, so yes, we did nitration now. Now let us write halogenation. In halogenation, alkenes, in halogenation, we have benzene ring, that is also known as arenes. So we have arene react with halogens in the presence of Lewis acid such as AlCl3, FeCl3, FeBr3, etc. to form haloarenes. So in the structure, we have a benzene ring. So this is a reaction. In the presence of anhydrous AlCl3, then you will get a chlorobenzene. So from benzene to chlorobenzene, so a chlorine group is attached on benzene. Chlorine group is attached on benzene. Okay. Next is when we have, let us look at the mechanism here. Let us look at the mechanism. So in mechanism, you have written the notes now. So tell me what is the first step in all of the mechanism? Generation of, please look at the mechanism and tell me. Yeah, generation of electrophile. Okay. Now you look at this. If I look at this reaction, now you tell me what will be the electrophile in this reaction. What will be the electrophile? Yesterday I told you guys now how to identify the electrophile just by looking at the reaction. So let me just show this. See, what did I say? In nitration, what was the electrophile? What is the electrophile in nitrogen, guys?
NO2.
NO2 positive.
Positive,
NO2 nahi.
sir.
NO2 positive. So what will be the electrophile here? In
Cl2
halogen
minus.
Cl2 क्यों होगा?
Oh,
Now again,
okay, sir.
look here. What is the electrophile? The group that is attached. So what is the group attached here? NO2, and we just give a positive charge to that. So NO2 positive, है ना?
Yes, sir.
So you saw the group. What is the group, guys? NO2.
NO2.
Now here, what is the group that is attached?
Cl.
So what will be the electrophile?
Cl plus.
Cl positive. Yeah, exactly correct. Cl positive will be the electrophile. Okay. So once you remember this, है ना? You remember this. इसमें I know there is a possibility of understanding things, but I will emphasize on learning and by hearting the things, how to see them. Now, once you know Cl positive, that means in the first step, you have to generate electrophile. Generation of electrophile. Then no matter what, you are going to make a Cl positive, है ना? You're going to make a Cl positive. So once you don't know electrophile, that will be a bit difficult. But when you know electrophile, then it will be slightly easier, and maybe you will be writing the correct steps even if you don't remember whole mechanism. Now, how to create this electrophile? So whenever you have the first step, there is the reagent and the conditions that is given to the reagent which interact with each other. So we have Cl2, which may look like this, plus we have AlCl3. Now we know that AlCl3 is a Lewis acid, right? It is a Lewis acid. That means it will accept a pair of electron. It is a electron pair acceptor, right? It is an electron pair acceptor. So it will accept these electrons of Cl, and since the sigma bond is broken and the electrons that was in sigma bond, it is given to the aluminium atom, we will be getting Cl positive plus this Al will be now AlCl4. Now, since aluminium got extra 2 electrons, it will get a negative charge here. It will get a negative charge. Here have got our electrophile. Next step, what is the next step, guys? What is the next step?
Formation of carbocation.
Yeah, formation of carbocation. Now, in formation of carbocation, what is going to happen? You'll have our benzene ring that is electron rich. And this is our electron-rich benzene ring because it has 3 pi bonds. Plus, we have a Cl positive atom. So obviously, let us look at these hydrogens. And with this pi bond, we are going to attack this Cl positive. Now, one thing I should just mention, it doesn't happens like this, but in your class, you have to learn it like this only. Essentially, what happens, we have this atom here, and the pi electrons is like this now. So this whole thing attacks on Cl positive, and we get something like this. First of all, Cl is attached here. Then there is some displacement through hydrogens, and then it attaches on the benzene ring to one carbon atom. But initially, it attaches on the whole ring. Okay, fair. So just to give that in your head, कोई आगे जाके chemistry लिया तो फिर पता चलेगा सालिम सर ने गलत पढ़ा दिया. So just telling you guys that the whole benzene ring first attaches, but here you have to write through one pi bond. So when one pi bond is attacking on the Cl positive, one of the carbon atom will make a bond. One of the carbon atom will make a bond with chlorine, and the other carbon atom will get a positive charge. So here we are writing chlorine, and here is the hydrogen, and here is the hydrogen of this carbon atom, and this will get a positive charge because it has 4 bonds, might just have only 3 bonds. Now, after we have made this, so we have formed the carbocation. You can also write the resonating structure of those this carbocation. This pi bond will move here, then the positive charge will get here, then this pi bond will move and the positive charge will get here. So on, you can write it. But right now, what we will do, loss of proton. The third step is loss of proton. Loss of proton. So here we have the Cl and H in this carbon atom. Here we have the hydrogen with a positive charge, and these are the pi bonds. Now we have this AlCl4 negative, right? Here we have AlCl4 negative. So it is like this aluminium with 4 chlorine atoms. Okay, and there is a positive charge here. Now one of the chlorine atoms, it attacks on this hydrogen and it forms HCl, and then you get AlCl3 as it is. So whatever is used as catalyst now, this AlCl3, it is helping in this reaction. It is helping in this reaction, but it is not getting consumed. Cl. Now when it attacks on this hydrogen loses this sigma bond, gives the electron to this carbon atom, and we get HCl plus we get AlCl3. Okay, so this is the mechanism in halogenation. Is this clear, yes or no?
Yes.
Okay. The next one is Friedel-Crafts alkylation. This is important. Okay, if the questioner is going to ask you a good question, it will be from Friedel-Crafts alkylation only. Friedel-Crafts alkylation. Now in Friedel-Crafts alkylation, we have a benzene ring. So you can write when benzene is treated with alkyl halide. Benzene is treated with alkyl halide in the presence of anhydrous AlCl3 or FeCl3 or FeBr3, any of the lowest acid you can use again, any of the lowest acid. And there is a question also in NCERT which says that, is there any other reagent that we can use? Is there any reagent that we can use other than anhydrous AlCl3 for the form in the Friedel-Crafts alkylation? So yes, FeCl3, FeBr3, these are the lowest acid that you can use. Okay, in the presence of anhydrous AlCl3, FeCl3 or FeBr3, it forms alkyl benzene. It's going to form alkyl benzene. So we have a benzene ring. We have a benzene ring, and the reagent is Rx. The reagent is Rx, and this is done in the presence of anhydrous AlCl3. And what do we get here? We get an alkyl benzene. So we get a R group attached here. So what is the electrophile? What is the electrophile, guys?
R plus.
Very good. R plus. है ना? अब देखते हैं कैसे बनेगा. Now we'll see how will we generate this R plus. So first the mechanism generation of electrophile. Generation of electrophile. So in this we have Rx, let us say RCl. So let us take one example in which we have CS3, Cl. Okay, CS3Cl. Plus again we have AlCl3. Now AlCl3 is again what? AlCl3 is Lewis acid. So again this bond will break. The chlorine will attack on this aluminium and you will get CS3 positive plus AlCl4 negative. Now, once you have generated the electrophile, what are these steps? Formation of carbocation, loss of proton, which is going to be exactly same. Yes or no? Please tell me. Look at these.
Yes, sir. Yeah.
है ना? So the next two step, you will be just copying. है ना? You will be like, थोड़ा सा तो mind लगेगा. You will apply a few bit of whatever you have learned from the formation of carbocation in the true electrophilic aromatic substitution, that is nitration, and then you have halogenation. In those two we have formed carbocation and then we have also loss of proton. So those two steps you will be writing at home. That is, next step is formation of carbocation. Third step will be loss of proton. Okay, can you guys do this? Please tell me na. Samaira, Sara, Zainab, आप लोग बताइए. Matthew to said yes. What about you guys? Yes, na, you can write this. Okay. Now, important point is the reaction that you have to note down, which is, let us try to make a few molecules. है ना? Question. अच्छा, yesterday we did some, ना? Yesterday we wrote 3. अच्छा नहीं, आपके साथ नहीं हुआ. Okay, fine. So as you can see, what will be the product here? What is the R group? Tell me. What is the R in alkyl halide? What is the R?
CH3.
So CH3 will be attached on benzene. है ना? So from benzene, what you have made? You have made methyl benzene or toluene. है ना? This is also known as toluene. This is the preferred name for this structure, that is toluene. Any doubt till here? No, right? Also write another reaction in which we have benzene, which is CH3, CH2, Cl, again in the presence of anhydrous AlCl3. Now tell me, what is the R group that will be attached here in the benzene ring? So here we attach methyl. What will be attaching here? What will be attaching here?
CH3, CH2.
CH2, CH3. Na? This carbon atom will be
CH2,
attached.
CH3.
Na?
Yes, sir.
CH2, CH3. Is this fine? Yes or no? Please tell me.
Yes, sir.
Yes.
Okay. The third one is important. Please remember this. Okay. This third one is very important. We have benzene ring plus CH3 CH2, CH2, Cl. The presence of anhydrous AlCl3. So here we have propyl, but when we do this reaction, we got isopropyl benzene. That means the carbon was the secondary carbon. CH3, CH3. So we had benzene and reacted this with chloropropane, 1 chloropropane. We expected propyl benzene, but we got isopropyl. Benzene. Okay, we got isopropyl benzene. Now, what is the reason for this? We will look at the reason. So first, the reason here is when we do the generation of electrophile, that is CH3, CH2, CH2Cl plus AlCl3. So we know that this bond will break and it will form a bond with aluminium. That means chlorine will form a bond with aluminium and we will get CH3, CH2, and CH2 positive like this. CH2 positive like this. Okay. Now this is the carbocation, which is very important. CH3, carbon, hydrogen, and a single bond. Then you have carbon again with 2 hydrogens, and there is a positive charge here. Yes or no? Is this clear with everyone? Yes or no? Please tell me.
Yes.
Okay. Now what happens? This hydrogen, one of these hydrogen. Okay. Here we have 2 hydrogens. So one of these hydrogen, it sees that there is a sigma bond here and there is a positive charge. Okay. So this reaction, it is completely possible like this. This reaction is completely possible. That we have CH3, carbon, and there we have hydrogen. In this case, CH2, and one more hydrogen. So this hydrogen has just shifted from one carbon to the other carbon, and here we have a positive charge. Now you can say that this reaction is also possible, Anna. As we just shifted the pi electrons. Why is this shifting? Now let me tell you, like with orbitals here. I will just show you 2 carbon atoms. Here there is a pi bond which is vacant, and here we have a sp hybridized, and here we have the hydrogen. Okay, and this is completely vacant, and here we have electron density. Now we know that electron it has a wave nature. Now electrons, it will be obviously attracted towards this positive charge where it is vacant. So sometimes what happens, the electron density moves here, like in hyperconjugation, the electron density moves here. Now when it moves, the hydrogen, it has the ability, it can go and it attaches on this carbon atom. Now it can also attach on this carbon atom back. So how we are writing the first reaction, in which this hydrogen atom is going to this carbon atom due to the positive charge. This hydrogen atom can also move to this positive charge. Okay, this atom can also move, but the system here that we have, it analyzes itself. Here it says that I am 1 degree carbon. I am 1 degree carbocation with only 2 alpha hydrogens. And here I am 2 degree carbocation with how many alpha hydrogens? I have 6 alpha hydrogens. Okay, I have 6 alpha hydrogens. So once it has moved to this secondary carbocation, it doesn't revert back because it is very stable. Because it is much stable than the 1 degree carbocation. Okay. So this is known as hydride shift. This is known as 1-2 hydride shift, which is very characteristic of carbocations. 1-2 hydride shift. Now we have the electrophile. Now the electrophile is what? Now we have the electrophile, that is CH3, CH with a positive charge, and CH3. Then obviously when it is attacking on benzene ring, then what is going to happen? When it attacks on benzene ring, so it will be attacking from the secondary carbon, that is the middle carbon here, and you will be getting the product, which is CH, CH3, CH3. Now is this clear with everyone? Yes or no? Please tell me. This part is clear, yes or no? 1 degree carbocation and 2 degree carbocation. 1-2 hydride shift.
Yes, sir.
Now, please, just try to remember this when you are going to the examination. You can get a question that when benzene is treated with 1-chloropropane, it forms isopropyl benzene. Why? है ना? Or they can also ask, when benzene is treated with 1-chloropropane, it should form propyl benzene, but it forms isopropyl benzene. Why? Then you have to show these steps that when you create an electrophile, that electrophile goes through a 1,2 hydride shift in the carbocation, and after that, the most stable carbocation, which is 2-degree carbocation, it attacks on benzene and forms isopropyl. It forms isopropyl benzene. So we can write like this. We can write like this. Since 2-degree carbocation with 6 alpha hydrogen is more stable, the 1-degree carbocation goes through a 1,2 hydride shift. 1,2 hydride shift to form 1,2 hydride shift, and you can write to form CH3, CH positive, CH3, and on attack of benzene, it forms isopropyl benzene. So the crux of this whole thing, that one thing that you have to remember is this 1,2 hydride shift. But like the teacher is looking for this 1,2 hydride shift and this portion here. The teacher, when he or she asks this question, they are looking for this word 1,2 hydride shift and this shift of 1 hydrogen. Okay, shift of 1 hydrogen. So since this reaction does not happen, that means this hydrogen bond here, it does not shift to the secondary carbon. So we are not showing that. We are just showing that the primary carbocation is transformed into secondary carbocation. Okay, secondary carbocation. Now, is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Next is Friedel-Crafts acylation. Friedel-Crafts acylation. When benzene is treated with acyl halide, or acid anhydride, in the presence of Lewis acid, it forms acyl benzene. So we have benzene ring plus acyl halide. Acyl halide is CH3, C double bond O, and Cl. Okay. Or one thing I can say that we can generalize it to R and X. Now again, in the presence of AlCl3, we are going to get here we have C double bond O and R group. So what will be the electrophile? Electrophile is going to be C double bond O R, and a positive charge will be on the carbon atom, because the atom which is bonded to the benzene ring will possess the positive charge. Is this clear? Yes or no? Please tell me. So there is some heat also required. Is this clear? Yes or no? Tell me.
Yes, sir.
Electrophile is fine. Na? Now, just the generation of electrophile. Generation of electrophile. Now, in generation of electrophile, we have the same thing here. That is R, C double bond O. Let us say Cl. Plus we have AlCl3. Now again, this pi bond will attack. Sorry, the sigma bond will attack on the AlCl3 atom because AlCl3 is the lowest acid with a vacant orbital, an incomplete octet, and we will be getting R, C double bond O with a positive charge here, and then we will get AlCl4 negative. Now, the next steps are similar. That is, after generation of electrophile, we will be getting here formation of carbocation, and the last step will be loss of proton. Okay. Now, here also, since R group can be different things, so let me write some questions. Write some questions for you guys. And also identify the reaction. So 4 reactions. You have to identify those reactions and also write the product. Okay. So you can write in the chat what are these different type of reactions and the name. You understood the question now? Yes or no? Do you guys understand the question what I have given? No. What happened? Can you please answer? Anyone? Matthew, Samaira, Sara, क्वेश्चन समझ में नहीं आया आप लोग को?
Understood, sir.
तो बोलिए. What happened? Samaira?
No, sir, I didn't understand.
What you did not understand? You can write the product. इतना समझ में आया आपको, है ना?
Yes, sir.
Okay. And identify the reaction. That means you have learned halogenation, nitration, acylation, Friedel-Crafts alkylation and Friedel-Crafts acylation, है ना?
Yes.
Samaira? वो लिखना है बस कि पहला वाला क्या है, नाइट्रेशन है, एसाइलेशन है, अल्काइलेशन क्या है.
Okay, sir.
Okay. Raise your hand if you're done. Okay, Samira is done. Samira, can you just click a photo and send it to Nishkarsh sir?
Okay, sir.
Okay, thank you. Okay, what about others? Matthew, Sarah, Zainab, आप लोग कर रहे हैं?
Almost done, sir. 1 second.
Okay. Okay, I got. Is Samira correct? Yeah, yeah. Oh, yeah, okay. Everything is correct. Good, good. What about Sarah? Sarah, आपसे हो रहा है?
Doing so.
Okay. नहीं हुआ आप लोग का? Matthew, Sarah, Zainab. Zainab, you are doing this? Yes or no?
Sir, I'm done. I'm just sending it to you. One sec.
Acha, okay. Okay, okay. Did you send it, Matthew?
Not yet, sir. Wait.
Okay, okay.
Sir, I sent in the chat.
They have sent in the chat only. Okay. Okay, look at the first question, Matthew.
Okay.
So in the product, how many carbons did you make?
3.
And in the reactant, how many carbons are there? Except the benzene ring. 3.
Oh no, sorry.
Got it.
Yeah.
Okay, no problem with that. Okay, now in the second question, look at the second question.
Yes, sir.
Can you understand what you have written?
Yes, sir. I cut it out at the end. So yeah.
So what should I understand with this?
Sir, it's just CH3 that like remove the rest of it.
Okay, so the bond will be with the middle carbon, like the secondary carbon, and the chlorine will not be there, right?
Yeah. Oh yeah, I forgot to add the chlorine in there.
You forget to add, you forget to remove.
To remove, sorry, yeah.
And then again, so small mistake only, है ना? See,
Yes, sir.
in HNO3, nitration is NO2, not
Okay.
NO3.
Oh, okay.
Okay, so you have to keep
Alright.
okay, and then it is fine again. But like when you were copying the question, you have written just FEBR. I think I wrote FEBR3.
3, yes, sir. Yeah.
So just take care of these small things, है ना? I don't know how
Sure,
your
sir.
teacher is he or she lenient or very strict. That will depend on the marks. Now, how you are getting the marks. So how is your teacher, lenient or?
I mean, like she's in the middle. Something like she's rather strict, but not very lenient.
Okay, no, but she is like lenient in marking or not lenient in marking?
Nowadays, she is not lenient.
Nowadays, she's not lenient.
Yeah,
Okay,
but for the cycle test, she was a bit lenient.
okay. And what happened to your handwriting? It
Sir,
seems
sorry,
like,
it's very rough. Yes. Yeah, my pen is not very good right at the moment.
okay, but I hope you have a better handwriting than
Yeah,
this,
I do,
right?
I do. Yeah, it's the
Okay,
most as rough as it gets. So.
okay, fine. Okay. So I received one more. Okay, this is from Zainab or Sarah? Who is this?
Sarah.
Sarah. Okay. Sarah, ये आपका like this is your what number attempt? पेंसिल से लिखने वाले लोग तो उनको नफरत है. I don't like people who write with pencils.
I did the first and the third one. I had confusion in the second one.
नहीं सेकंड वन तो ये नहीं होगा ना. देखिए अच्छा यहाँ से आप ये बताइए बस सारा that when we are breaking this bond ना when this bond will break like this. इतना आपको दिख रहा है कि नहीं दिख रहा है ये बताइए आप. Can you see this happening?
Yes, sir.
You can see this happening. Then tell me you have one carbon, second carbon, and third carbon. Now which of these carbon will be in which of these carbon atoms will we generate a positive charge? In which of these? In
Second.
which of these? Second carbon. अच्छा जब second carbon में positive होगा, so benzene will attack on which carbon atom? 1, 2, or 3? Tell me. The benzene will attack on which carbon atom?
2.
2. If the benzene will attack on second carbon atom, then the bond will be formed between benzene ring and which carbon atom? 1, 2, or 3?
2.
2. है ना? So I don't know. You gave all the answers. लेकिन आपने आंसर में कुछ और लिखा है. So first thing is that you know that this bond is going to break. So chlorine तो आपने हटा दिया. You remove the chlorine, then you had CH. है ना? ये bond बनेगा. Then this carbon is attached with CH3, and then this carbon is also attached with CH3. So like please take look how I write the products. What I do, I first of all identify the electrophile वहाँ जहाँ पे attack होने वाला है, right? On that carbon atom which is going to form a bond with benzene. So I write that carbon first. Now I look at this carbon, how many hydrogen it has? It has 1 hydrogen. Then this carbon is also attached to the first carbon. So this is the CH3 group, but that is it is attached to, and this is the CH3 that it is attached to. Okay, so this is the way of writing all the products. Now here also, this bond will break and it will be gone to AlCl3. And the positive charge will be created on this carbon atom. So first of all, I will write the benzene ring and I will make a bond with that carbon atom only. Now I will look at here and see that this bond has to broken. This carbon has a double bond oxygen. So I will make a double bond oxygen like this. Then I will see that this carbon atom also has a CH3 group. Okay, this is carbon atom has also CH3. Nitration, you don't have to worry about nitration because nitration you just add NO2 group, nothing else. Now here in halogenation also you just add a Br. This is bromination to be exact. Br group. Okay. Okay, fine. So I think you guys have like you just need to practice a bit more. Otherwise, everything is fine till now. Okay. Then the last one is sulfonation. Okay, the last one is sulfonation. So let us write about sulfonation. Okay, there's one more reaction that I should write. This is the 5th reaction. See, you will remember everything. You will remember everything, but you will forget this reaction. So I'm just making a star mark, and the probability of this reaction is also very less. You will, I will not say that remember this reaction. I will just say that before going to the examination, look at this 5th reaction. Okay, look at this 5th reaction. So just in case they gave you benzene ring plus anhydride. Anhydride is CH3, C double bond O with oxygen, and then you have carbon, C double bond O, and CH3. Okay, now you have to compare this and the acyl chloride. If you compare these two, then you can see this is CH3, COO. Now this carbon atom is attached to an electronegative atom. Here also we have the same entity CH3, C double bond O, and this carbon atom is attached to an electronegative atom. And then we are going to react this with again AlCl3 only. Okay, so the first step is this bond. Here we have this carbon Cl bond. Here we will have carbon oxygen bond. It will break and it will transfer this to aluminium. So okay, so we are not going into the mechanism here of acetic anhydride because it is not in the syllabus. But you should know that whenever we use acetic anhydride, we will be getting acyl benzene here also. Okay, here also we will be getting a benzene ring. This carbon, this bond will attack on this aluminium. This carbon will get a positive charge. Okay, so this bond is broken already. We have here carbon. This carbon is attached to a double bond O. And here we have a CH3 group. Carbon is also attached to CH3 group. Okay, why I'm saying this? Because this example you will not very much see in the NCERT exercises also, but it is mentioned in the text. So they can give this question also. Okay, so just look at this question before going to the examination, before going to this examination. Next is sulfonation. Fifth one. Sulfonation. Fifth one is sulfonation. So in sulfonation, what do we have? We have benzene ring. Plus H2SO4. Concentrated H2SO4. And in the presence of a bit of heat, what do we get? We get SO3H. So the electrophile here, it is HSO3 positive. HSO3 positive. Is this fine? Please tell me yes or no. This is benzene sulfonic acid. Benzene sulfonic acid. Now this may seem like strange to you, but थोड़ा सा revise करने के लिए, can I write this reaction? Please tell me. H2O liquid plus H2O liquid is in equilibrium with H3O positive plus OH negative. Yes or no? Tell me. Can I write this? We have written this in equilibrium. Water acting as an acid and also a base. This is the self-ionization of water. Yes or no?
Yes, sir.
Yes.
है ना? ये तो हमने लिखा है. ये तो हमने लिखा है. Okay. That means I can also write H2SO4 plus H2SO4. It will be in equilibrium with. It will be in equilibrium with. So one of this carbon atom, one of this hydrogen atom will be abstracted by one of those sulfuric acid, and we will get HSO. Let me show you the whole reaction as I showed you with the nitration also. Sulfur, double bond O, OH, double bond O, OH, plus sulfur, double bond O, OH and double bond O. So here we have this lone pair, here we have this lone pair, attacks on the hydrogen atom, and it forms H, which is bonded to oxygen. It is again bonded to another hydrogen. It's bonded to sulfur, double bond O, OH, double bond O. Here we get a positive charge. Here we get a positive charge. Plus, now this is what? This is HSO4 negative. HSO4 negative. Now this water molecule, it gives this bond, it gives the electron to oxygen. Now this transforms into H, sulfur, double bond O, OH, double bond O. Here we get a positive charge, and this is what? Plus H2O you will get. So from this water, HOH positive charge, this bond is broken, and you are getting H2O. Now this is my electrophile. This is my electrophile, that is HSO3 positive. Right? This is my electrophile HSO3 positive, and here we have the positive charge on sulfur atom. That is why sulfur will be attached on benzene. Sulfur will be attached on benzene. So please tell me, is this clear? Yes or no?
Yes.
What about others? Zainab, Sarah,
Yes.
all of you clear? Yes or no? Okay. Now there is another mechanism. There is another mechanism in which they say that we have SO3 molecule that is also present. That is also present. If you look at H2SO4, it can decompose into water plus SO3. So whenever you have H2SO4, there will be some sulfuric acid. There will be some oxide of sulfur which will be present. Okay, there will be some sulfur oxide. So there is another mechanism in which you have the benzene ring. This is the benzene ring. Now, this benzene ring is attached, it is attacked by the SO3. It is attacked by the SO3. So now you know that SO3 is going to be a Lewis. It is going to be a Lewis acid. Why? Because sulfur, it has a D block, and D block is what? D block is vacant. The D block is vacant. So we have this reaction in which, let me show you guys like this. Sulfur trioxide, double bond O. So this benzene attacks on sulfur. We get sulfur, double bond O, and one of this O negative, it goes like this. You get O negative. And we all know that, we have H2SO4. So from H2SO4, you will get H plus ions. So this H plus ions will be attacked by this SO3O negative, and you will get benzene sulfonic acid. As you can see, it is very similar to this. It is not very similar. It is exactly like this one. So both of these mechanisms are possible. Both of these mechanisms are possible when you have benzene plus concentrated H2SO4 plus concentrated H2SO4. So for electrophile, you can write SO3 positive, or you can also get, or SO3 is the electrophile. Okay, or SO3 is the electrophile. So nowadays it is SO3 is more accepted nowadays. Okay, so if you have an MCQ, then you will write SO3. If you don't have an MCQ, then you will write both of them. Is that clear? Yes or no? Tell me.
Yes, sir.
Okay, so generation of electrophile. Now we have the two steps that is remaining. Okay, so sulfonation is also done. Now we have to look at effect of substituent groups, effect of substituents on effect of substituents on electrophilic aromatic substituents. Sorry, electrophilic aromatic substitution reactions. Okay, that means what will happen if I have a OH group here? Okay, what is going to happen if I have a NH2 group here? What is going to happen if I have a CH3 group here? So these things, we have to consider these things. What is going to happen if I have a carboxylic acid group and I react this with any of those electrophilic aromatic substituents, substitution reaction that we have done: nitration, halogenation, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. So what is the effect of these substituent groups? What is the effect of these substituent groups? Okay, so for this, let me first of all tell you that there are two effects of substituent on EAS. Write it a bit more properly. Effect of substituents on electrophilic aromatic substitution. Okay. Now, we have benzene ring that we will be comparing with. Okay, and let us write two different types of groups. Here we have D. Here we have W group. Okay, here we have W group. What does D mean? Electron donating. W means electron withdrawing. Is this clear? Yes or no? Please tell me. Donating group and withdrawing group. Is this clear? Yes or no?
Yes.
Yes.
Okay. So first of all, let us talk about the reactivity. How fast a particular reaction is going to happen in comparison to benzene. So what are we going to see here? Please tell me. What did I say? Just repeat it with me. How is the reactivity compared to benzene? What are we looking here? What are we looking here?
Reactivity.
reactivity compared to benzene. So this is benzene derivatives and D donating groups, and there are some withdrawing groups that are attached. Okay, donating and withdrawing group. Okay, now benzene in this, when we have electrophilic aromatic substitution, so benzene is the one which is giving electrons, yes or no? Yes or no, guys? Benzene is the
Yes.
one which is giving. All of you, please tell me. Samira, Sarah, Zainab.
Yes, sir.
Yes. Okay. Now, if benzene is giving electrons, that means in this benzene ring, if I want to increase the reactivity, so I can say the reactivity is what? Reactivity is proportional to the electron density. Yes or no? Yes or no? Tell me. If we will have more electron density in the benzene ring, then the reaction will be faster. Yes or no?
Yes, sir.
All of you agree. Okay, so now you can tell we have donating groups and we have withdrawing group. We have donating group, we have withdrawing group. So we have A, we have B, that is benzene, and we have C, that is withdrawing group. Now in this case, I can say that electron donating group, they will be giving more and more electron will be pumped in the benzene ring when we have a electron donating group. Yes or no? Yes or no, guys?
Yes, sir.
Okay, so A will be fastest. The reactivity of A will be highest. Yes or no? If I have a donating group, then A, that means those benzene derivatives which have electron donating groups attached to it will have the highest reactivity, followed by benzene rings, and then followed by C, that is the withdrawing groups. Is this clear? Yes or no? Please tell me.
Yes, sir.
All of you?
Yes, sir.
Yes.
Okay. Now, let us look at another thing. हम चलते हैं अब ऑर्गेनिक केमिस्ट्री लास्ट क्लास ऑर्गेनिक केमिस्ट्री लास्ट क्लास है ना now let us look at a few things that we studied. Okay, mesomeric effect में चलना है, not last class, second last. Okay, हाँ चलिए second last चलते हैं. देखिए प्लस एम देखिए आप लोग. All of you, can you see this? Yes or no? Please tell me.
Yes, sir.
Okay, can you see that in this benzene when we have a plus M group, then the ortho positions and the para position, it has more electron density. Yes or no? Correct?
Yes, sir.
All of you can see this, na? Introduction of plus M group increases the electron density at ortho and para position. Hai ki nahi?
Yes,
You have this in your notebook also. Now you tell me, if there is more electron density at ortho and para, there is more electron density at ortho and para, then if we have a donating group, then the attack, it will be, I can say that if I have a plus M group, then I can say the attack will be either from the ortho position and from the para position. Correct?
yes, sir.
है ना? So I will be getting two products. So one product will be if I attack from the ortho position. So here we will be having any of the plus M groups, and we will get a ortho substituted product, plus we will also get a para substituted product, because we have electron density that is higher at ortho and para positions. Is this clear? Yes or no?
Yes, sir.
What about Matthew?
Yes, sir.
Sarah?
Clear.
Clear,
Yes,
na?
sir.
Okay. Let us see what happens in minus M. So minus M में क्या हो रहा है बताइए? What is happening in minus M? We are decreasing the electron density at ortho and para positions. Correct?
Yes.
So we can definitely say that the attack will not take place from ortho and para position. So what position is left now? We have only meta position is left. Although now there is no effect on the meta position. So meta position is constant, but ortho and para have decreased the electron density. So obviously, which is going to attack? Which position is going to attack here? If in minus M, what position is going to attack? अच्छा ये बताइए भी. हाँ बोलिए. Somebody turn their mic on.
Beta.
Meta position will attack. Very good. है ना? Meta position is going to attack. So here we have benzene ring attached with plus M. Sorry, नहीं, plus M तो हो गया, minus M. Minus M group. Now in minus M group, there is only one position that is going to attack the electrophile, which is the meta position, अब बस आपका एक ही काम बचा, to identify plus m and minus m. Okay, to identify the plus m and minus m. So I will be making a few groups here, and then you will tell me which is plus m and which is minus m. Okay, after that we can write all of these things down. Write the question. Identify. याद है कि नहीं याद है आप लोगों को? बताइए तो प्लस एम एंड माइनस एम, कि मेरा मूड खराब होने वाला है, बताइए। समायरा, मैथ्यू, सारा। हाँ गाइस, you can identify plus m minus m. नहीं ना?
Yeah, I guess so. Yeah, I guess.
You have your notebook, Samaira, Matthew and Sarah, all of you, right? Zainab?
Yes, sir.
हाँ, तो थोड़ा pages को पलट लीजिए. Go to that page where we have discussed this, है ना? And I will give you same questions. ठीक है, हम questions भी दिखा दे रहे हैं आपको. Just ये है कि आप लोग इतना तेज ना निकल जाइए कि आप लोग आंसर ही देख के रख लीजिए, है ना? ये देखिए, ये सवाल है यहाँ पे. Can you see this question sum? यही हम देंगे, है ना? All of these questions will be same only. तो इवन आप थोड़ा सा कॉपी करके ही जवाब दे दीजिएगा, ठीक है? I just want you guys to revise it. There will be a few new ones also, not exactly same. Identify the plus m and minus m groups, plus m and minus m groups in following. So I will be starting with one of those groups that you may not have the answer. That is if you have a alkyl group attached. So अगर आपके पास alkyl group होगा, then it will be plus m. तो ये हम बता ही दे रहे हैं आपको. And this is going to be CH3. This is going to be electron donating group and through plus m, and how plus m, that is through hyperconjugation, वो बाद में देखा जाएगा जब कभी जरूरत पड़े तो. अभी I am just writing this plus m. And after this you have to write. Okay, so let me just copy the benzene ring that I will be going to draw. A lot of benzene rings here. सर कटा हुआ है सबका. Okay, so let us start. OH, NH2, COH, CHO, C double bond O, CH3. Achha, let me write one more. CH2, CH3, and NO2. Also CN. Then what else? Nitrogen, which is double bond O, CH3. So amide group is also no. And SO3H. Then you can have carbon, which is having a double bond, and oxygen. Then you have CH3. Yeah, you can have this group also. Then you can also have oxygen, which is bonded to C double bond O, and CH3. Yeah, you can also have this. है ना? चलिए चालू हो जाइए आप लोग. प्लस m and minus m. You have 3 more minutes and I will start discussing. I've got 2 more minutes. Yeah. So tell me, for the first one it is plus m. For the second one, guys, बताइए. Matthew, Samaira, Sara. हाँ बोलिए मैथ्यू.
Plus m.
Size.
जो अच्छे से बोलिए आप लोग, एक तो है ना, ऐसे मम्बल रैप टाइप का बोलते हैं आप लोग. हाँ,
Plus m.
Plus m.
थैंक यू वेरी मच. थर्ड वन,
Plus M.
बाकी लोग नहीं बोलेंगे क्या? समायरा, सारा. प्लस एम ना समायरा?
Yes.
ओके. फोर्थ वन, जोर से अच्छे से. प्लीज कीप योर माइक ऑन. थोड़ा
Yes,
जल्दी
sir.
कर लेते हैं. समायरा, सारा, आप लोग बताइए.
Minus m.
ओके. समायरा.
Minus m.
मैथ्यू, वाई प्लस एम?
So it's donating group, right? Oh,
नहीं
never
नहीं,
mind.
वो तो नहीं.
COH. Never mind. Okay, okay.
वाई, हाउ डू वी सी माइनस एम और प्लस एम? पहले तो माइनस एम ही देखते हैं ना हम लोग. फर्स्ट ऑफ ऑल वी सी वेदर इट इज अ माइनस एम और नॉट. हाउ डू वी सी माइनस एम? द की एटम. ओहो ओहो ओहो, आपने तो नहीं किया है हमारे साथ ऑर्गेनिक केमिस्ट्री, है ना मैथ्यू?
Yes, sir. I was
हाँ हाँ
there.
हाँ, ओके. हाँ, तो देख लीजिए थोड़ा हिंदू वीडियो. ओके, दिस इज द सेकंड लास्ट आई थिंक लेक्चर ऑफ माइनस. सो व्हाट यू हैव टू सी, देयर इज दिस concept of key atom. Key atom here is the carbon that is directly attached to the benzene ring. So this is the key atom. Achha, what will be the key atom here in the fifth one? Carbon again, है ना?
Yes, sir.
Now is it connected to a electronegative atom? Is carbon connected to electronegative atom in CHO group?
No. It
अरे,
needs,
carbon is connected to what atoms? Tell me. CHO कौन सा होता है?
H.
कीटोन. Only H, और H के बाद ऑक्सीजन लगा है क्या? आप लोग भी गजब है. It is like this ना?
Yes.
CHO.
Mm-hmm.
So it is connected to a electronegative atom via double bond. So whenever the key atom is connected to electronegative atom via multiple bond, it is a minus M group. So this will be minus M. Sixth one, बताइए समायरा सारा. Sixth one will be minus M. Seventh one
Plus M.
plus M, है ना, because alkyl group. Eighth one
Minus.
Minus.
minus M. Matthew, minus M है ना?
Yes, sir. Yeah.
Okay, ninth one
Minus M.
minus M. Key atom connected to more electronegative atom through multiple bond. 10th one बताइए.
Minus.
माइनस नहीं होगा यहाँ पे, देखिए. नाइट्रोजन is connected to carbon ना. Carbon is not more electronegative. Also, it is only connected with a
Positive.
single bond, है ना. यहाँ पे बस हमने H देना भूल गए थे. My bad. But again, it doesn't make any change. And here we have nitrogen has lone pair electrons. So if it has lone pair electrons, then it is not minus M, and it has lone pair electrons, so it will be plus M. Yes, Samaira, Sara.
Yes.
Correct?
Yes.
Okay. Sulfonic acid SO3H plus M or minus M? Plus M or minus M? Minus M. Sulfur bonded with oxygen. Okay. What about this 12th one? Plus M or minus M?
Minus.
Minus again.
Minus M.
Bonded with oxygen.
Okay. Now 13 one, it will be. What is the key atom here?
Oxygen.
Oxygen. And oxygen is connected to any
Carbon.
electronegative atom. Ah, yeah. So it is not connected to any electronegative atom, right?
Mm-hmm.
And oxygen, you know that it has lone pair electrons, correct?
Yes.
Yes.
So it will be plus M. Correct? Yes or no? Tell me.
Yes, sir.
Yes.
Yes, sir.
Okay, बस एक और लास्ट हम लोग कर लेते हैं. That is of any halogen atom. If you have benzene ring plus any halogen, so halogens have 3 lone pair electrons. So it will be also plus M. Correct? Yes or no? Any problem? Any problem, guys?
No, sir.
No problem, na? Okay. So now let me tell you guys effect on EAS. So we have just now seen there are two different type of effects. Effect on electrophilic aromatic substitution. So you have two different types of effect, that is either on the orientation, like orientation, that means on which position will the electrophile attach. Orientation. So when you have orientation, then you have this group attached. Now you can either have product on the ortho and para position or on the meta position. And what orientation, it is controlled by plus M and minus M, that is through resonance. Then another is reactivity. So reactivity, it controls the comparison of reactivity with benzene. It is controlled by electron donating groups and electron withdrawing groups. Okay, electron withdrawing groups. So the highest will be electron donating groups. They are the highest in reactivity, followed by benzene, and then those which have electron withdrawing groups. So electron withdrawing groups are least, and in between there is benzene. Okay. Now we have seen with orientation. So पहले हम लोग वही करते हैं. Like in orientation, we have either orthopara. We will have either orthopara. अच्छा नहीं. Let me write it like this. Orientation. So when you are talking about orientation, then we can classify the groups into two types, plus M or minus M. So if it is plus M group, we can either have a plus M group or we can have a minus M group. Now, when we have a plus M group, then we are going to get ortho para, ortho and para substituted product. That means the electrophile attacks will be attacked on from the ortho position and the para position. And if I have a minus M group, then we know that the more electron dense site is what? The meta position. So we'll get only meta substituted product. Meta substituted product. Okay. So first example I'm giving. We have phenolic group and we are doing nitration. That means we are adding HNO3 in the presence of H2SO4. Now, first of all, tell me what is the group that will be attached? The electrophile is NO2 positive. So NO2 positive will be attached. Now tell me, it is plus M group or minus M group?
Minus.
Plus M or minus M? OH है भाई. What happened, Samaira? OH ना? OH कौन सा ग्रुप है भाई, ये बताइए ना. OH रिएक्शन तो यहाँ से हो रहा है ना. NO2 तो अभी लगा नहीं है. NO2 लगेगा तब तो माइनस M होगा. अभी क्या है?
Plus M.
Plus M है. तो कौन? So we will get how many products? 2 products. Ortho and para.
Yes.
Correct. So बस देखिए. You first of all practice it, है ना. आप लोग कर लीजिएगा प्रैक्टिस. 10-20 क्वेश्चन हो जाएंगे तब आपको समझ में आएगा. For now you just practice. So you will have OH as it is, and then you add NO2 group in the ortho position. Okay, NO2 group in the ortho position. So this will be now ortho substituted, and in ortho position we have nitro group, and this is the whole thing is what? Phenol. So this is O nitrophenol plus I will get a P nitrophenol, 2 products. Plus M group, we have 2 products, ortho and para. So this will be P nitrophenol. Is it clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, same reaction, but I have changed the substituent, that is now it is cyanide. So first of all, see the benzene ring, the benzene derivative, and tell me plus M or minus M? Plus M or minus M? बोलिए. अरे क्या हो गया?
-M.
Minus M है ना. C triple bond N होता है. So how many product? Only 1 product. Meta substituted. Meta substituted. That means, अच्छा, you guys know ना ortho, para and meta positions.
Yes, sir.
Yes, sir.
हाँ, वो नहीं पता होगा तब तो दिक्कत हो जाएगी, है ना. CN. So tell me on which carbon? 1, 2, 3, 4, 5 or 6. Which carbon should I attach the NO2 group? मेटा पोजीशन कौन सा है इसमें? Why are you guys
3
silent?
and 5.
हाँ, 3 or 5 है ना. Any one of them, because 3 and 5 both are same only, right? As 2 and 6
Yes,
are
sir.
same. Okay. So we'll attach on the NO2 here. Okay. So this will be M nitro benzonitrate. Benzonitrate. ऐसे लिख देते हैं. Cyano and nitro. Cyano will be higher. 1 cyano, 3 nitro, benzene. Okay. Now I'm going to give you some questions. Okay. I'm going to give you some questions. Can you write the answers? Yes or no? You can, no?
Yes.
Yes.
Okay. and also unidentify the reaction. वही तो नाम लिखना है आपको. What type of reaction is this? Halogenation, alkylation, or whatever it is. H2SO for me, we don't need it. So just need some heat. Okay. A, B, C. Okay, C के बाद D होता है, हमने F लिख दिया. Okay. I hope you can write the answers. So just after writing the answers, send a photo. Okay. I'm giving you 5 minutes. Okay. Not more than 5 minutes. And when you are sending the answers now, so please write your name also in the same sheet. और प्लीज जो लोग रफ कर रहे हैं वो रफ में ही एक बार भेज दीजिए, एक बार रफ करके फिर फेर मत कीजिएगा. यस गाइस, डन। जी बताइए। डन 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 नहीं। ओके, यस। मैथ्यू, समायरा, सारा,
Doing, sir. Last question.
Sir,
लास्ट
rejected.
Doing.
डूइंग। ओके ओके ओके। अच्छा, वेर यू गाइस नोटिफाइड अबाउट द वाइवा? हाँ, मैथ्यू, समायरा, सारा, बताइए। वेर यू गाइस टोल्ड अबाउट वाइवा? ओके, साइलेंस मींस यस ना?
No,
Yes,
sir.
Matthew.
No, sir.
नो, समायरा?
Not really.
Yes.
ओके, व्हाट अबाउट सारा? आपको ही बताया गया होगा ना वाइवा
Yes.
के बारे में? ओके, देन do this question, then we'll have the viva, and this is the end. Okay, this is the end, and I will send you notes mein there will be a few more things that you have to write. Okay, so for example, we have done this reactivity part, but we did not write anything substantial here. So I hope you understood that why the reactivity is higher in electron donating groups and why it is lower in withdrawing groups. So you have to write that also. So I will just paste those things, whatever you have to write in the notes, and then you can just copy. So you don't have class tomorrow. Okay, well, that you have the extra class now, you're not going to have that tomorrow, but on Tuesdays and Thursdays, Monday, Wednesday, Monday and Wednesdays, that you have your class timing na, as of now today, आज जैसा timing था, we will have this for you guys only. आप निष्कर्ष सर को बताना कि सर हमको क्लास लेना है, I have these topics that I have to study and I will be there. Will that work for you guys? जी बताइए।
Yes, sir.
Matthew and Samaira?
No. Okay, sir.
Okay, you understood now what I said? Hydrocarbons is हाँ
Okay,
बताइए।
so we need to stay in the meeting and study.
No,
Is that
not
what
say
you-
in the meeting. No,
Oh,
not
okay.
say in the meeting.
Then-
So the syllabus is complete, right?
Yes, yes.
तो अब क्या पढ़िएगा आप?
All right.
So what will you study now? You will either study 12th standard that you can't study before the examination. So you will be only studying the doubts, right?
Mhm.
So if you have any doubts, then like for example, Monday you have class na 2 hours. So that will be for you guys only. But उसमें क्या पढ़िएगा वो थोड़ा पहले बता दीजिए, है ना? That you will be attending the class or not attending the class. If any one of you also is available, and if any one of you also have doubt and they want to attend the class, then I will be there. But I don't want to be just keeping the meeting on. I will keep the meeting on, then you come and go like that.
Oh,
We will not
okay.
do like that. बस inform कर दीजिएगा पहले कि सर I want a class. आपको सब्जेक्ट बताना, मैथ चैप्टर बताना नहीं बताना वो अलग बात है. You don't mention that also. Just tell me that I have some doubts. I want a class on Monday. So same timing जो Monday and Wednesday को होता है, you will have your class. Okay, चलिए. So I am writing this reactions. So tell me first of all, plus M or minus M? Plus M or minus M? A1.
Plus.
अरे प्लस एम कैसे?
It's minus M.
माइनस एम ना, COH. Was it सारा और समायरा? सारा. माइनस एम है ना सारा?
Yes, sir.
फिर अच्छा, अल्का क्या है, रिएक्शन कौन सा है? नाइट्रेशन, सल्फोनेशन, हैलोजिनेशन, फ्रीडल क्राफ्ट एल्काइलेशन और फ्रीडल क्राफ्ट एसाइलेशन, कौन सा है?
Critical alkylation.
Alkylation. Okay, very good. Alkylation, and that means first of all, if it is minus M, then we will have only one product, that is the meta product. So I will make the COH as it is. Benzene ring बन गया हमारा. Then I will add on meta group the CH3. Alkylation. So we are adding the alkyl group. Okay. What about B? Plus M or minus M?
Minus M.
Minus M. कौन बोला अभी minus M? समायरा.
Yes, sir.
माइनस एम कैसे है? NH2 तो अभी आपने लिखा नहीं क्या आपने प्लस
Plus
एम?
M, right? Because it
Yes,
describes
yes, plus M.
method.
ओके, क्या मतलब, लाइक आई डोंट नो व्हाट इज हैपनिंग. अभी आपने प्लस एम बोला, अभी आप माइनस एम, मतलब डजंट मेक सेंस. What is the confusion here, Samaira? Sara ने भी just like उल्टा ही कर दिया. Okay, what is the reaction here?
Alkylation.
Alkylation. अरे एसाइलेशन है ना भाई साहब, क्या कर रहे हैं आप लोग? ऐसे कैसे चलेगा? CH3 C double bond O and we have Cl group here. This is acylation, and so we will get two products. We will get a ortho product C double bond O CH3, again a benzene ring with NH2, and here we will be getting C double bond O CH3. What is this one? C1 plus M or minus M?
Minus M.
minus M.
Now tell me what is the reaction?
Halogenation.
Okay, so how many product? If minus M, then how many product? One product or two products?
One.
बताइए. One product. That is on meta position at a Cl group. Okay, what about this one? Plus M or minus M? The last one. Plus M or minus M?
Plus M.
Plus M. That means orthopara. Ortho we will get SO3H. Plus we will get also a para product which is OCH3. Is it clear, yes or no? Okay, for Viva,
Yes, sir.
I will ask you only one question for all of you, and you will send the answer in chat. Okay, only one question. PR will attach on which carbon, 1 or 2? In the chat. अच्छा, एक ही सवाल पूछें या एक और सवाल पूछ लें? What do you guys think? What will be better for you guys? अच्छा, ये जवाब अगर किसी को आ रहा होगा तब तो वो नहीं चाहेगा. So let us see. The PR will attach on which carbon? First carbon or second carbon? कोई नहीं पढ़ रहा है या नहीं? हाँ? No one is. अच्छा, is there anything else that I said? कुछ और प्रिपेयर करके आए हैं क्या आप लोग? बता दीजिए प्लीज.
Sir, I send the answer.
You have sent the answer. Okay. Samaira ने नहीं भेजा, मैथ्यू नहीं भेज दिया आंसर. Samaira, what happened?
Sir, I sent already.
हाँ, मैथ्यू का नाम ही नहीं लिया हमने. समायरा से पूछ रहे हैं हम. समायरा,
Okay.
I've got your answer. समायरा, okay. तो आप दोनों तो गए, मैथ्यू एंड समायरा. आई डोंट नो हाउ कैन यू गेट दिस रॉन्ग. हाँ, लाइक सेम क्वेश्चंस अगर हमने कराए हैं, मार्कोनिकॉव और एंटी मार्कोनिकॉव, बताइए मैथ्यू एंड समायरा. समायरा टेल मी, मार्कोनिकॉव और एंटी मार्कोनिकॉव? नहीं, पढ़ाई चालू कीजिए आप लोग. ओके, स्टार्ट स्टडीइंग. समायरा, क्या हो गया? कैन यू टर्न दी माइक ऑन, समायरा?
So from alkanes, right?
अच्छा, तो वही हम पूछ रहे थे. आई हैव गिव यू सम डिफरेंट थिंग्स. ओके फाइन. सो यू वांट मी टू आस्क अ क्वेश्चन फ्रॉम alkenes?
Yes, sir.
ओके फाइन. व्हाट अबाउट यू मैथ्यू? आपने तो नहीं, आप यू डिड नॉट गेट एनीथिंग अबाउट द वाइवा?
Sir, I have exams going on right now, so I didn't really know about it.
नो अबाउट? वो नहीं पूछ रहे. मैसेज तो आया होगा ना, लाइक यू डोंट चेक मैसेजेस और व्हाट?
So I must have gone message, but then I had exams, so I must have like ignored it. I don't know, but yeah,
Okay.
I was not informed that we had Viva today.
टुडे का बात नहीं है. लाइक यू मस्ट हैव बीन इन्फॉर्म्ड लाइक a week before only that you will have viva on the next week. Okay, so let me ask you a question that is from alkanes, right? Alkanes. Okay, Samira, you tell me, alkanes are polar or non-polar? Start with easy one. Alkanes are polar or non-polar? Samira, okay, fine. I got the answer. They are non-polar. Okay, fine. Okay, and tell me, if I increase the branching, then the boiling point and melting point, what will be the effect of increasing the branching? I can also say that compares CH3, CH2, CH2, CH3 versus CH3, CH, CH3 and CH3. Which will have a higher boiling point, 1 or 2? Which will have a high boiling point, 1 or 2, Samira? Okay, good. Good. Okay, so one question from the chemical properties. Okay, one question from chemical properties. So there is not much in the chemical properties, but again, so you tell me, chlorine will attach on which carbon? 1, 2 or 3? What will be the major product on which carbon? So I will be getting two products, Cl, Cl. So you can answer anything, A or B, which will be major, and the carbon will be attached on which carbon atom. Which will be the major product? You can also answer any one of the questions. Same question, just different way of saying it. Yes, tell me, Samira. Okay, fine. Chalo. Thank you very much. Thank you, Matthew. Thank you, Samira. Bye bye, guys.